Hello, welcome, good afternoon to our practical learning session Valve Drive Controller VCS and Control Element with RTC as Slave for the function heating. My name is Thorsten Reibel from the Competence Center Europe Smart Buildings. Yeah, we continue now the series of learning sessions with HVAC and KNX, again the Valve Drive Controller, but now a real KNX room operating element working as a slave to have the combination HVAC and room temperature control. Yeah, it's for heating again. Further sessions will come, but to this topic we come later. Yeah, session takes around 30 minutes and I hand over to Jürgen. He will present this today.
Hello and a warm welcome to this practical learning session ClimaECO, ABB IBUS, KNX and HVAC. My name is Jürgen Schilder. Today I will show you the practical application of heating in a room with the Valve Drive Controller VCS as a controller and a control element with RTC Slave device function. After an introduction on our ABB ClimaECO HVAC solutions, I will show you the parameterization in the ETS and then live the function in operation. The focus is on a live demonstration and I'm only showing you some slides at the beginning.
ABB offers a holistic automation solution for heating, ventilation and air conditioning based on ABB IBUS KNX. This allows a seamless integration from the room level via distribution and central HVAC functions to the management and automation level. This is a significant step towards increasing energy efficiency and reducing operating costs. The ABB ClimaECO portfolio includes the ClimaECO sensors and room control units, valve drive controllers, fan coil controllers, heating cooling circuit controllers, the boiler chiller interface. For the management level, we have the application controller ACS with the interface to BACnet, and on top our building automation controller KNX BUX, which is our PLC with KNX interface. We have given numerous webinars and learning sessions about all these products. You can find the video recording and the webinar slides in our training and qualification database. Here you can see an overview of our ABB IBUS KNX HVAC range. On the left side, we have our room operating elements, different designs, for example, the Solo, or we have here the Tenton, Tacteo, Pinonia, and other devices, other ranges. Additionally, we can use also the presence detector or air quality sensor, or only an analog input with a temperature sensor to measure the temperature or do also the controlling. In the middle, we have our actuators. A wide range of products started from the typical fan coil controller. Here we have 9 different devices, the valve drive controller, electronic switch actuator, up to our room master with built-in fan coil actuator or our room controller. And on the right side you can see our devices for the distribution, the heating cooling circuit controller, boiler chiller interface, and the 2 devices for our automation level, the application controller with the interface to BACnet and our PLC with KNX interface. So today we put a focus on our room temperature sensor here as a slave. So this device measures the temperature and we can set here also the set point. But the controlling is done here in our valve drive controller VCS. So this is exactly the exercise we want to do today. We want to do the individual room temperature control temperature control in a typical office. So we have here our control element with the room temperature controller, but this device works as a typical slave, so not controlling. Our controller is here the so-called valve drive controller. So this device here controls our valves. So on the output we have our valves, which gives more or less hot water for the radiators and heats up the room. With our control element, we want to measure the temperature, the actual temperature in the room. We want to set the target temperature, the set point, here with these 2 rockers, up and down, and we want also switch off and on our control. So plus the display is used for showing us the actual temperature and also the set point and the different operating modes. Via some our control elements here, or via time switch, or via, for example, a presence detector, we want to switch between the different operating modes. Such a typical room temperature controller can have 4 operating modes, so-called comfort, the room is occupied, Standby, the room is not occupied, maybe over the lunch break, some minutes. And also the echo. Echo means for a longer time, like over the night or over the weekend. And the fourth operation mode is so-called frost or heat protection if a window is open or, for example, the device is switched off. Good, then let's start with this exercise. So we have here our valve drive controller. On the binary input, we have connected here a window contact, typical magnetic grid contact. So the advantage is we can internally link this binary input to our controller, so we have not to assign a group address. On the output, here we have our valve drives for the radiators. So in the room we have a presence detector, which switches to the comfort mode if the room is occupied. If the room is unoccupied, then it switches to the comfort mode, which was before, like standby, or also the echo mode. So with the control element, we measure the temperature and send it to the controller. Plus, via the rockers, we can switch on and off the controller and change here the set point plus minus 3 kelvins. So a time switches between the operating mode, switches via this group object operating mode normal between the night mode or echo mode and the standby mode. A higher priority has a so-called operating mode override OMO group object. With this object, which is used, for example, from a visualization or BMS system, switches with the highest priority between the auto mode. Auto mode means the next lower priority is now valid, or we go to the frost protection mode. So here you can see these different priorities of the elements. Started with the lowest priority. This is our operating mode switching normal, which is simulated here by a time switch. The next higher level is the presence detector here, which gives us the information room occupied or not. Then the next higher priority level is the controller on and off, and followed by the window contact. And the highest priority is our operating mode switch override, which is here simulated by our visualization or BMS system. So this is exactly the priority levels of a room temperature controller. Good, then let's do it in practical. And I share now my desktop, and we start with setting the parameters in the ETS. So on the right side, you can still see our exercise with the devices and the different operating modes. So on the left side, I have here the ETS, prepare the project. So I start at first with the valve drive controller. So we start with the typical parameters, the general, but for this exercise we can keep all these general parameters and also for the manual operation. And we start here with our channel number A. So we start here with the first sub-parameter, sub-menu, application parameters. So in here we have one of the important parameter, the channel function. Is it used as a controller or only as an actuator? I said, okay, it's a controller, so I keep here the settings controller. So then we come to the next, basic stage heating. Yes, we have connected a typical radiator, or you can select here, like for example, area heating system, a floor heating system, or freely configurable. So I use here the radiator, and then the controller uses automatically the algorithm which fits here to our convector with the P and the I values. The additional stage for heating is not used, so deactivated, and basic stage cooling is not used, so I go here to the parameter deactivated. And now you can see here, this is a little bit yellow highlighted. I have activated here the button highlight changes, and then I can see all changes which were made instead of my standard parameters. Okay, deactivated, and I get less parameters, less objects, which makes maybe the parameterization easier. Good, so, and we continue here with the window contact. I say, yes, we have a window contact, and it's connected to the physical device input. Physical device input means here the right side, the window contact is here wired to one of the binary inputs here on our valve drive controller. The temperature input comes from our control element, so we have to select here the parameter via group object. So via group object, the temperature comes here to our controller. So maximum, the controller can listen to 2 different temperature inputs, but at the moment we have only one control element, so we keep it like it is here with one control element. So channel function, so we can use all the standard parameters, so we keep it like the parameters are, and then we come to our temperature controller. Here, for example, we get some more information about temperature controller. but we don't want to use it because it's only a sensor. Then we skip it and we go to the setpoint manager. In the setpoint manager, we can select the 4 operation modes. Do we want to use all 4 modes? Comfort, standby, eco, building protection? I say yes, or if you want less operating modes, then you can reduce it here. But we want to use all 4. So the operating mode after bus voltage recovery or ATS download is here default comfort, so we keep it like it is. The setpoint specification adjustment, we use the relative setpoint adjustment. What does it mean? We enter here the comfort heating setpoint, 21 degrees, and then the setpoint for standby and economy is now relative. It means we enter here value 2 kelvins. So what does it mean? Our standby heating setpoint is now 21 minus 2 Kelvin equals 19 degrees. So here we have 19 and here for echo we have 17. The advantage of the relative set points is now when we change this comfort heating set point via KNX telegram, the standby and the economy also follows the changes. So when we change it here to 20 via KNX telegram, the standby is now 18 and the other one 16. Or you can see they select here absolute and then you can enter here absolute values. But I prefer here the relative. Plus the set point for our frost protection, typically 7 degrees. Good, and for heating it's not important at the moment. So then we come to monitoring and safety. Here we can activate the forced operation, but this is not topic of today, so we also skip here the monitoring and safety parameters. Then we come to our valve output A. So at first we can enter here the type of our valve output. Is it the thermoelectric valve, which uses the pulse width modulation, or only an open and close signal or deactivated? So I think the best solution is to use the pulse width modulation. So depending our valve drive, we have to set here the parameter. It is de-energized, closed or open. Typically it's a closed valve. And then we have to enter here the pulse width modulation cycle time. So now we have selected here pulse width modulation, and then we have to enter here time. So what's the meaning of this time? So for a typical radiator, we have to enter here about 15 minutes, and for a floor heating system or area heating system about 30 minutes. So what does it mean? The controller inside calculates to open the valve, for example, 50%, but the valve can be only open or close. And then depending here our pulse width modulation cycle time, the valve is opened for so many minutes and closed for the other part of the minutes. So for example, if I enter here a value about 15 minutes and the controller calculates 50%, and then the valve is open 7.5 minutes and the valve is closed 7.5 minutes. Or for example, the valve is open 80%, the controller calculates 80%, and then 80% of this time the valve is open. So here I use here my training board to see the behavior only 10 seconds, to be a little bit faster, only here for the training. Remember, in a real installation, radiator 15 minutes, floor heating system 30 minutes. And we can also enter here a time for the opening and closing time of the valve. Typically, such a thermoelectric valve drive needs between 1 and 2 minutes from open and from the position close to open. So here in my training, I use only training boards only 10 seconds. Good. So we keep all the other parameters. Valve purge, no, we don't use it, so we keep it like this. And then we come here to our input. Input A and input B is not used, but our input number C. And the input number C, I have connected here the window contact. Here exactly on the input number C is my window contact, and depending my parameters I have made, it is linked now to the controller. Good, so far these all are the settings I have to make in the valve drive controller, and then let's come here to my control element with room temperature slave. This is the room temperature controller, which is also built here inside. This is the Tenton, but to show you today the slave function, I select here later no room temperature control. That's only a slave device. Of course, this device is also available with only slave function, without room temperature control function. Then let's start with some device setting parameters like general. It makes sense to display the actual temperature, so I say here yes, and if I want to use here the Celsius or Fahrenheit, I can change it. And I want to see here the actual temperature of the controller. So this is which the device measures. So to see here exactly temperature which is measured here with my control element. So I say EAS, and if I want to see other values, I can also enable the other values. So what else? We come to our next parameter, so we can skip also the primary function. We come here to room temperature control. Here's now very important to say you are not a controller, you are a so-called slave device, because he communicates via KNX to our controller, which is the master. So select here the parameter slave. So then we come to the next function here, additional function objects. Yes, then we get more parameters and more options which we need between the master-slave communication to our controller. So operating functions, what do we want here? Switch over, fan coil. No, we have no switch over between heating and cooling, no fan coil during heating, no between cooling. Then we get less parameters and less group objects, which makes us the parameterization easy. So then we come to changing the set values, our set temperature. Here we can enter the step size, 0.1 degree, 0.2 or 0.5. So every time when I press here on the left or on the right side of my rocker, I change the set point in 0.5 step size. And for the communication to our controller, is it via absolute temperature value or 1 byte or relative? We use here the default settings because the valve drive controller has here as default the same parameters. So then we come to the temperature reading. Here we have to change it to the internal measurement. It means the internal temperature sensor is now used for measuring the temperature. So here we can also send the time for the cyclical sending of the temperature to the controller and also the difference for sending. Good, so far these are the settings we have to make here in our room operating element. Do not forget, the important one is to say you are not a controller, you are a slave. And then we can use our rockers here, our different rockers or the gangs for additional function. One is, for example, for switching on and off. So when I press on the left side, I want to switch on the right side off, or vice versa. Then I have to use here the default parameter 2-button switching, and then maybe default first button, which is the left one, off, and the second one is here for on. So my second function block or my second rocker, I want to use it for adjusting of the set point. So when I press here the left on the right side, I want to change the set point, maximum plus minus 3 Kelvin. Then I have to select here the function, where is it? 2-button RTC function internal. Internal means this is an internal function that we have not to link a group address between here changing the set point to our controller. So we go here to the parameter, and then we have two possibilities. One is for changing the set values. Yes, that's what we want. Or we can also, when we have a fan coil unit, for the fan stage adjustment. But here we want only change the set point, left minus, right plus, yes, or vice versa. What do you want? Good, okay. And additionally, if you want, we can also have another button. For example, we have here the so-called 1-button operating mode, adjust thermostat settings. When I say yes, then I get here the possibility to change here via this button the operating mode between comfort, standby, eco and frost protection is also possible. Good, okay, so far the parameters we have to make in our room operating element, like here in our 10-ton, and the next step is to create group addresses and link the group addresses between here our element and our valve drive controller. So to see the group addresses we have to link, I go now back to my presentation. Here on this slide, you can see the group objects of the devices. On the left side, my presence detector with the object is a 1-bit object, movement, the time switch, this is a 1-byte object. A 1 byte according to the data point type 20102 HVAC mode to switch between echo and standby. So depending on the value, this byte here, if the value 2, then it goes in the echo mode, and standby is the value number 1. And here I have a visualization or BMS system which uses the same data point type to switch between the frost protection and the auto mode. So in the middle we have our fan coil, our valve drive controller VCS, which works as a controller with all our objects to send here the status of the window contact, presence detector, external temperature, and so on. And on the right side, we have our control element, our RTC Slave Unit. And here we have also a wide range of objects. And the next step is to link all these objects. So then let's start here with the left side, our presence detector, a 1-bit group object, link it here to the object controller presence detector. Okay, then before we come to the next one, here we want to switch between the operating mode, normal, between echo and standby. So we have to link the group address here to the object operating mode, normal. And for the highest priority, we want to link here our visualization of BMS system to switch between the auto mode and frost protection mode. Then we link it here to our operating mode override. So then we come to the group addresses we need between our controller and our control element. The important ones is of course our actual temperature. So this device measures the temperature and sends it here to the input external temperature of our valve drive controller. So plus all the other objects we have to link between our master and slave. So we see here on the left side, we have, for example, here the operating mode normal master. We have to link it here with normal operating mode slave. So we have to make a link between all the master objects here to our slave objects. The same, for example, for RTC on-off confirmation, or for example here for the on-off request. Here we need an additional link to our rocker number 1, because with the rocker number 1, we want here to switch on and off our room temperature controller. That's why we have to link here also this group address. So it's not very difficult. Yeah, you have a look here on the master objects and link it here to the different slave objects in our room temperature slave unit. Good, this is what I show you now live. But before we come to the live demonstration, here another possibility. What happens, or what should we do when we need 2 slaves in our room? So we will have maybe an open plan office. So with the first device, maybe in this corner, we want to measure the temperature and operate our controller. And the same with a second device, which is installed in the opposite side of the room. We want to measure also the temperature, and also we want to control the device. Then we link all the objects. You see here, for example, operating mode normal from our master to the first slave, and the same group address also to the second slave. So this is the advantage. If you need more than 1 operating elements, you can link here the same group addresses, like between master and our slave number 1, link the same group address to the slave number 2. The only thing we have to take care is about our actual temperature. So we have to go to our valve drive controller and enable here the external temperature number 2. Then we get here a second object, and here we link the group address, which is measured here by our second control element. So here we need another group address, and then we can set here parameter, and then he makes maybe a 50-50 calculation. So he uses 50% of this temperature and 50% of this one, or you can set also other parameters. Good, then let's come to the practical demonstration. I go now back to my ETS. So here I have still done all linking of the group addresses and made a download. So everything is now finished. So we can continue now. So with the camera, you can see now here our Tenton, the room operating element, which works as a slave. Here the valve drive controller with the switch for simulating the window contact, and my control element here for simulating presence and, for example, comfort and standby. Good, then let's start with testing. But to test all the things, I use here our ABB IBUS tool. This is a software which is free of charge, and with this software we can test all the settings we had made in the ATS. So I need only the individual address of my valve drive controller 4161, and then I make a point-to-point connection between the IBUS tool and the valve drive controller. And with the IBUS tool I can test all the settings, simulate also, for example, window open signal, or I can temporarily change the set points and all the things, and test if I made all the parameter settings correct. If not, then I close the IBUS tool, go back to the ETS, modify my settings, link more group addresses if I missed one, and make a download. So via the IBUS tool we cannot make a download, link or group addresses. It's only for testing all the parameter settings we have made here in the ATS. Good, then let's come here to the IBUS tool. You see here on the first page the status. At the moment we are here controller. This is my parameter. I said you are the controller. So the current room temperature is 20 degrees. So I can simulate it. For example, here we are this potty. We'll do it later. We see at the moment the basic stage heating 0%. So what does it mean? He is not heating. And no other things are at the moment active, no alarms, the window is closed, no forced operation. And now if I open the window by using here the switch, then you will see window is now open. You see it here via this orange square. So, okay, my window contact now is working, everything is fine. Then I can go to the next page, my so-called controller page. And here I see at the moment we are in the heating mode. I have set a parameter, heating, no cooling. I see the operating mode. We can have comfort, standby, eco or protection. And here at the moment I see the set point temperature of the standby mode. I have set 21 degrees for comfort and relative set point 2 Kelvins. That's why I see here 1921 minus the 2 Kelvins. So, and the basic stage heating, my actual value 0% because my room temperature is now 20 degrees and my set temperature 19. So I change now the operating mode. So I go now here in my room. Rocker number 1 simulates here my presence detector. I go in the room, presence detector detects me, and you can see the operating mode here has now changed. Now we are here now. The person is in the room, is in the heating mode, and here our 21 means this is our set point. And 20 degrees, this is here my actual temperature. So we see here on the output, the red LED is on and off. And remember my cycle time, my pulse width modulation time is now 10 seconds. And we have here control value of 56%. So 56% of my 10 seconds, the output is on, and 44% it is off. So 5.5 seconds, the LED is on, and 4.5 seconds, the LED is off. Good. Then I switch here to other mode. For example, I switch here off. So I press here the button. What can you see? He goes to the protection mode. The room temperature controller is switched off. You see the new set point, 7 degrees. I can do something, for example. I can open here also a window. Nothing happens because we are still here in our frost protection mode. Good. So then let's switch on, close the window and switch on again the controller. Then we go back to the operating mode like before, comfort mode. I open now the window. Then you will see he goes into the frost mode. You see here the icon which shows you an open window and our current temperature, and we are here in the frost protection mode, 7 degrees. Okay, close the window. Then I leave my room, so the room is not occupied. And then you will see he goes back to the so-called standby mode, 19 degrees our set point. Rocker number 2, I simulate here my time switch to switch between the operating mode echo and standby. So maybe at the evening, 8 o'clock, the time switch, then the command, go to the echo mode, and then you will see my new set point are now here 17 degrees. In the morning, 6 o'clock, the time switch, then the command, go again to my standby mode to 19 degrees. And then when I enter the room, presence, and then I have here my 21 degrees. Good, and remember the highest priority here is my operating mode switch over. So this comes here from a BMS system. So now it's simulated here via the rocker number 3. So the BMS sent here information, highest priority, frost mode, and then you will see he goes again here into the frost mode. You see here the icon, frost mode, and my control value 7 degrees. You can now do something what you want. You can change here to echo mode. You can switch off. Nothing happens. The highest priority is here the so-called override mode. And then the BMS system sends a 0 auto, and then he goes to the last command. Remember the last command was here my echo mode. And again, I come here in my office, I switch on, then I still go back here to 21 degrees. And you see here my control value, 56%. I change now here my current room temperature. I turn here a little bit of potentiometer, and with this potty I can reduce my temperature. It's here simulation tool, and then you will see my current room temperature now goes to a little bit more, 7 degrees, a little bit higher. Again, so we have to wait some seconds. So at the moment we have here now 14 degrees, then we'll see my basic stage heating full 100%. Because my set point, now here 21 degrees, full 14. Or I increase the temperature here in my room. I simulate here, let's wait, here about, come on, 44 degrees. And then you will see, of course, the basic stage heating, our control value is, of course, 0%, independent my operating mode. Room is not occupied. Here's in the echo mode. Then we have 17 degrees. And of course, we have here the control value is 0%. Good. And here of the page outputs, we can see here our actual value of the position of the valve. We can see if the forced operation is active or the valve purge. And with the inputs, we can see here the status of all three inputs. Remember, input C is here my window contact, window open or close, which I can test here. And what I also can do, I can also simulate here my window contact. If you have no possibility to go to the window and open the window, you can activate here the so-called configuration mode. Yes, and then we can simulate here some values. Like here in the controller, we can switch between our operating modes. We can change here the set point, so I can enter here a new set point. Or here, for example, in the inputs, I can click here on the button and simulate that someone opens the window and see exactly the behavior. You see now, window is open. Here I have overridden via this button the value, and you can see, oh yes, everything is okay. Here my valve drive controller goes into the frost mode. Everything here is okay. Good. So far, I think I'm the end of my practical demonstration, not only presentation. Thank you for your participating and listening. I'm now giving the word back to Thorsten. Thanks and good.
Thank you, Jürgen. So a further solution with our HVAC components, valve drive controller working as a controller, and the ABB or the KNX room temperature element working as a slave only. In our valve drive controller, also later in the fan coil controller, we have always controller integrated, so we can use it free of charge. And then we need less performance in the room operating element. And keep in mind, for the 10-ton range, there is also a pure slave version available. Means there is no controller inside. Of course, it costs also less, and exactly this solution can then be created, just shown by Jürgen. Let's come to my final slides as always. So you find everything on the homepage and also our training material in the training database. Yeah, what is planned next? We continue on Thursday this week, again with the valve drive controller. But then the valve drive controller only is an actuator and a real room temperature controller in the room. So situation is a bit different from the situation today, but another option. We show you also how to program this. And then we come to cooling with valve drive controller finally. And then we continue with fan coil control, starting also with an online learning session to show this principle first of all in general, and then to our different solutions with all the components we have. So then I say thank you for your participation, and hope to see you next time, maybe on Thursday. Okay, bye-bye, ciao.